Good afternoon. Once again, yours truly, Dolphy Gilpin, here with you in the closet on the second floor of 1524 LaVista Drive, Decatur, Georgia, United States of America. And I'm on the amazing 5x12 matrix application in confined spaces, synonymous with pilots and astronauts having to work in confined spaces, small areas for long hours. We are also on its application in the aircraft modeling, and since we have thrown around a lot of parameters and there are ambiguities into what these parameters represent, I'm going to once again refresh our memories here in the closet in Georgia, Decatur, what these parameters represent, so that you will have a better understanding of what is happening. So we have now the definition of the aircraft state space vector. Definition of the aircraft state space vector. All right, so what we have now is U. U, V, W, P, Q, and R. We say now the U is equal now to longitudinal forward velocity of the aircraft. V is equal to the lateral or transverse velocity. W is equal to the vertical velocity. P is equal to the roll weight, P. Q is equal to the pitch rate. And R is equal to the yaw rate. So here we have it, the definition of U, V, W, P, Q, and R that we are consistently using in describing these aircraft dynamics, statics, and kinematics. Okay, also we'll be using now X sub E, Y sub E, Z sub E, omega, so the probably pi or theta, and this one is phi, all in the uppercase, or psi rather. Pardon my Greek language representation. Okay, so we have it now as that's equal now to Earth fixed X position, XE, Y fixed, Earth fixed Y position, and Earth fixed Z position. Roll angle, this is omega. Roll angle, theta. Pitch angle, sine. Yaw angle, I think this is the NED, northeast downward, and H is the altitude. And our last representation now, we have forces, moments, and defined in similar manner. Forces and moments. These are all we'll be using our description of our aircraft dynamics, statics, kinematics, and our correlation with the Amz5x12m matrix. So we have now X, Y, Z, L, W, M, N. L, M, and N. That's equal now to longitudinal forces, transverse forces, Y, vertical forces, Z, roll moment, L, pitch moment, M, and yaw moment, N. So there we have it for most of the parameters that we'll be using in this description of these aircraft dynamics, statics, and kinematics. And with respect to our Amz5x12m matrix correlation, these are the parameters as being used. So I hope that that there will be no more ambiguity as to when some of these parameters have been thrown around without much emphasis. I'm going to assume that you already know them. There are some other lowercase parameters that have to be defined, but when I come to that bridge, we'll all cross it and make the description more apparent and give it more clarity. So we'll take a break from here with our definition of aircraft dynamics parameters, and we'll return with our application of the Amz5x matrix in confined spaces.